All right, let's talk about one of the trickiest papers in IGCSE biology, paper 6, the alternative to practical exam. Now, this isn't about what you can memorize from a textbook. Nope, it's all about how you can think. So, over the next few minutes, we are going to break down the exact skills you need to turn this paper from a challenge into your secret weapon for getting that top grade. So here's our game plan. First, we'll crack the code to see what the examiners are really looking for. Then we're going to build your skills step by step, pillar by pillar. How to plan like a real scientist, how to observe and record with razor-sharp precision, and how to analyze your data like a detective. And you'll want to stick around to the end because I've got a final checklist that will lock everything in for exam day. First things first, let's get inside the heads of the people who make this paper. See, if you want to beat the exam, you've got to understand the game. And trust me, the game is probably not what you think it is. This right here, this is the golden rule. You have to forget about cramming facts. This paper isn't a memory test, it is a thinking test. They want to see how you handle a problem you've probably never seen before. Can you think like a scientist, right there on the spot? That's the real question. So what on earth does that mean for you? Well, it all boils down to what the syllabus calls AO3 skills. Don't worry about the jargon, it's just a fancy way of saying they're testing your ability to plan, record, and analyze experiments. And the best part? These are skills, not just random facts. And like any skill, you can practice them until they're basically second nature. So let's jump into our first pillar, planning. This is all about how you design a solid, logical, and scientifically sound investigation, right from scratch. This is where you lay the foundation for some serious marks. Okay, before you even write a single word of your plan, you need to stop and ask yourself 3 quick questions. First, what am I deliberately changing? That's your independent variable. Second, what am I going to measure to see what happens? That's your dependent variable. And third, what do I have to keep exactly the same to make sure this is a fair test? Those are your constants, and nailing them down is absolutely critical. Think of this as your recipe for the perfect plan. You've already got your variables, now you just need to list exactly how you'll control your constants. Your method needs to be so clear that someone could just pick it up and follow it like instructions. But here are the 2 big ones students always seem to forget. Including a control so you have something to compare your results to, and saying that you'll repeat the experiment. Repeating it isn't just good practice, it's how you prove your results are reliable, and it's basically free marks. Oh, and a quick mention of safety, it shows the examiner you're thinking like a real scientist. And look at this. This is how it all comes together perfectly. This is a top-notch answer for an experiment on how temperature affects seed germination. See the constants? Same type of seed, same damp cotton wool, same access to air. The thing being changed, the independent variable, is temperature. You've got one set in a warm lab, the other in a cold fridge. And that fridge setup, that's our control. It's a beautifully logical plan. Awesome. So you've planned a flawless experiment. Now you need to show you can handle the data. This part is all about presenting your observations clearly and precisely. We're going to focus on the 2 big ones, biological drawings and data tables. Okay, you open the paper and you see this. The question asks you to make a large labeled drawing of it. Your first thought might be, oh no, I'm not an artist. But I've got really good news for you, you absolutely do not have to be. The secret here is that it's not about art. It's about following a very strict set of rules. A sketchy, shaded drawing might look cool, but it's going to cost you marks. The examiner is looking for something else entirely. They want to see large, clean, single lines drawn with a sharp pencil. They want ruler-straight label lines that touch the exact feature you're pointing to. Remember, this is about scientific communication, not winning an art contest. It's all about clarity. And here's what that looks like in practice. See the difference? The outline is clean, it's unbroken. The drawing is big. The label lines are perfectly straight and they point exactly to the eye and the muscular foot. And notice, no shading at all. This is the kind of drawing that gets full marks every single time. Okay, drawing's done, but wait, you're not finished yet. Very often, the next part of the question is going to ask you to calculate the magnification of the drawing you just did. Don't let the math scare you off. This is one of the easiest calculations you'll do. The formula is always the same. It's the image size divided by the actual size, just like you see here. All you do is measure the length of your drawing, then measure the length of the original image in the question. The only trick is to make sure your units are the same. I'd stick with millimeters. Then you just divide. And please, show you're working. Even if you mess up the final number, you can still get marks for using the right method.
All right, we're on to our final pillar. You've planned a solid experiment, you've recorded your observations like a pro. Now it's time to put on your detective hat and figure out what it all means. This is all about graphs and conclusions.
You know, just like with the drawings, graphing is a test of precision, not being a great artist. This checklist right here is your key to getting full marks. So first, the setup. Use a pencil and make your graph big. It should fill at least half of the grid they give you. Second, the labels. This is a big one. Your axes must have both the quantity and the unit. And remember, the variable you controlled, the independent variable, it always goes on the bottom, the x-axis. Finally, the data itself. Plot your points with neat, clear crosses, and then draw one smooth, best fit line or curve. It's a system, and following it shows the examiner you are organized and precise. That same precision applies to your data tables. The headings have to have the quantity and the units. See how the units, like degrees Celsius or seconds, are only in the headings, never next to the actual numbers? And check out the rate of reaction column. The decimal places are consistent all the way down. It's all about being neat and systematic. And now for the conclusion. Here is the #1 mistake people make. They just repeat some scientific fact they memorized. No, your conclusion must come directly from the data you're looking at. So don't just say, higher temperatures increase enzyme activity. Instead, you have to say something like, as the temperature increased from 20 to 40 degrees Celsius, the time taken for the starch to disappear decreased from 120 to 32 seconds, showing that the rate of reaction increased. See? You have to quote the data to back up your claim. Okay, deep breath. We've covered the 3 pillars: planning, recording, and analyzing. To bring it all together, here is a super quick, rapid-fire summary of what you absolutely have to remember. All right, this is it. This is your last-minute mental checklist before you walk into that exam. So let's run through it. For any planning question, ask yourself, have I included a control and said I'll repeat it? For any drawing, is it big, clean, and unshaded? For any graph, are my axes fully labeled with units? And for every single question, am I linking my conclusion directly back to the data? Burn this checklist into your brain and you'll be on the right track. And that brings us right back to where we started. Remember that golden rule. Paper 6 is not a memory test. It's a skills test. The examiners don't care if you've personally done this exact experiment before. What they care about is whether you can think like a scientist. So walk into that exam with confidence, not in what you've memorized, but in your method. Think logically, plan carefully, and let the evidence guide you. That right there is your key to a top grade.